Hey makers, welcome back. Today we're assembling this 3D printed Ford Flathead V8 engine designed by Eric the Pool Boy. You can download the STL files from the link below. And inside that download, there's also a PDF guide with all the suggested print settings and part names. This whole engine took about 3 days to print and around 1.7 kilograms of filament. You can go wild with colors. I use gray, black, white, red, blue, and gold. If you love 3D printing plus engines, hit subscribe now so you don't miss the next build. We're doing more 3D printed engine kits step by step right here. Quick smart hack before you start building. Instead of wasting hours sourcing screws and bearings one by one, I'm using the complete hardware kit from MakerRx for this Flathead engine kit. It saves you from getting the wrong sizes, waiting for multiple deliveries, and that moment when you're one bolt short at 1 a.m. The MakerRx kit even includes extra hardware, just in case something rolls under the table or you misplace a nut. After you double check your printed parts and hardware kit, prepare these tools. Super glue, 1.5mm and 2.5mm Allen keys, a bit of lubricant/grease for cam lobes and bearings, sandpaper or a file for cleanup, and a soldering iron for electronics and heat inserts. Once you've got all that ready, we can start the assembly. Let's start with the engine block, the foundation of everything. First, clean up your prints. Knock off any stringing or blobs so the parts sit flat and tight. Now we'll add disc magnets anywhere the block needs to snap to other parts, front, top, and bottom. Put a small drop of glue in each magnet pocket and press the magnet in. Important, keep the polarity the same on all of them so parts attract, not repel. Next, we'll install the threaded inserts. I use a soldering iron to heat set the inserts in all the mounting points around the block, front, rear, and bottom, but you can also use a drill. See PDF guide if you're using a drill. This is what will let us connect on the timing cover, heads, and oil pan later. Once your block is prepped and the inserts are in, we can move on to the moving parts. Time to build the crankshaft, the backbone of this engine. We'll start with the center main bearing assembly. On screen, you'll see the order, but it goes like this. M3 by 20mm screw, crankshaft part 3, center bearing surface, 6701 ZZ bearing, crankshaft part 4, and finally an M3 nut. Tighten that down, but make sure the bearing still spins smoothly. Next, we'll build the rod bearing assemblies. Use crankshaft part 2, a connecting rod journal spacer, a 6700 ZZ bearing, and an M3 by 35mm screw. Stack them like in the PDF, tighten, and repeat for all the connecting rod bearings on the other side. Now for the front end, the crank gear and pulley assembly. Attach crankshaft 1 to the center bearing assembly, then assemble the crank gear, crank pulley, and 6701 ZZ bearing using an M3 by 50 screw. Secure the center bearing assembly to crankshaft 1 with an M3 nut. At the rear, build the rear main assembly with the rear bearing surface, a M3 by 40mm screw, a 6701 ZZ bearing, and an M3 nut. When everything is together, double check the total length of your crankshaft. It should be about 10.07 inches end to end. If anything feels crooked or tight, loosen, realign, and try again. A smooth crank now means a satisfying engine later. We'll drop this into the block after we finish the camshaft. Now let's build the camshaft, the part that tells the valves when to open and close. Start by inserting the threaded rod into the cam gear. Lock it with an M3 nut and a lock nut on one side. After we're done loading everything, we'll lock the other end too. Slide on bearing retainer 1, a 6701 ZZ bearing, and cam bearing seat 2. Now we can start adding the cam lobes, beginning with number 1. Make sure the numbers on all cam lobes face the front of the cam. Tighten them evenly along the rod so you don't bend or bow the shaft. And don't forget, all the notches on the cam lobes must line up. This keeps everything timed correctly. After cam lobe 8, slide on another bearing, then cam bearing seat 1, and lock it with a nut. This secures the first half. Then continue with cam lobes 9 to 16 in order. Finish with another bearing, cam bearing seat 3, and a nut plus lock nut on the end of the threaded rod. Now we can insert the camshaft into the engine block. Gently slide the cam into the block, lining the bearings up with their seats. As you push it in, make sure the cam lobes are centered under the valve holes. This alignment is important. It's what makes the lifters and valves move cleanly later on. With the cam in place, it's crankshaft time. Set the crankshaft into the block on the main bearing surfaces. Use the main bearing caps, including the rear main, and secure them with M3 by 12mm screws. Tighten them down gradually, alternating sides so the crank pulls in evenly. On the rear, you can also assemble and attach the flywheel now. Up front, we have one critical step. Align the timing marks on the crank gear and the cam gear. Those little marks are what keep your cam and crank synced. If they're not lined up, the valve timing will be off. Once lined up, rotate the crank by hand. It should turn smoothly with no big tight spots. If it feels wrong, back up, realign, and try again. Next, let's build the water pumps. For each water pump, take a M 3x25mm screw, add a 623ZZ bearing, add the water pump pulley, lock it with a M3 nut and a M3 lock nut. Do this twice, one for the driver's side and one for the passenger side. Then mount both pumps to the front of the engine block using M3x8mm screws. Tighten them snug so they don't wobble, but make sure the pulleys still spin freely. Now for the fun part. Pistons and rods. Take a piston and a connecting rod. Slide the rod into the piston and secure it with an M3x20mm screw and an M3 nut. Tighten it enough that it holds, but still allows smooth movement. Repeat this until you have 8 piston assemblies lined up. To install them, slide each piston down its cylinder from the top. Line the connecting rod with the crank journal. Secure it with the connecting rod bearing cap on the crank. Repeat until all 8 pistons are installed. Now spin the crankshaft slowly. You should see all 8 pistons moving up and down. This is the moment every car nerd loves. If any piston binds, take it out, lightly sand, and try again. Next up, valves and lifters. This completes the valve train. Start with the lifters. Take a valve lifter. Screw in an M3x6mm hex head screw from the bottom. Make 16 lifters like this. Now the valves. Cut down an M3x45mm screw to the correct length. Slide on a spring retainer, add the valve spring, then the valve guide, and finally the valve itself. Again, make 16 full valve assemblies. To install, 1. Drop the valve lifters into the block facing up. 2. Then insert the valves with springs and guides from the top, lining each one over its lifter. 3. Lock each valve guide with an M3x8mm set screw. Check that the valves still move. You want them to travel, not get clamped solid. Time to build the cylinder heads. This is where the flathead starts to really look like a flathead. For each head, insert threaded inserts into the 2 side mounting holes. Use an M3x6mm hex head screw where required. Thread in 28 M3x8mm set screws into the stud holes. Install 4 spark plugs into the plug holes. Then add 24 M3 acorn nuts onto the studs. It's a bit repetitive, but the result looks amazing. It really sells the engine. Flip the head over and glue magnets into the pockets on the bottom. Again, check polarity so they match the magnets in the block. Repeat the whole process for the other head. Let's add some detail parts. The fuel pump and air filters. For the mechanical fuel pump, screw a M3x6mm hex head screw into the pump body. Attach it to the oil breather tube with an M3x8mm screw. For the air filters, glue the filter parts together. Make 2 complete filter assemblies. Set them aside for the intake later. Now for the intake manifold. First, thread M3x8mm set screws into the intake manifold. Lock them with M3 nuts where needed. These act as studs. At the front, insert 2 threaded inserts. Flip the manifold over, put glue into the magnet pockets, and press in the magnets. Again, match the polarity with the rest of the engine. Now stack the top side. Screw the upper intake manifold on with M3x8mm screws. Mount the throttle body on top, then bolt the assembled carburetor, lower and upper, onto the throttle body spacer. Glue the air filter on top of the carb. Finally, mount the fuel pump assembly to the intake using a M3x12mm screw. Set the completed intake assembly aside. We'll drop it on after the heads. Let's build the headers. This is where the flathead gets interesting. For each header, insert M3x8mm set screws into the header and lock them with M3 nuts. Add a bit of glue into the magnet holes, insert the magnets, and make sure the polarity matches the block. Once both headers are done, they'll later snap onto the block with a satisfying click. Now we'll assemble the generator. Use an M3x30mm screw and slide it through the generator body. Then add 2 3mm washers, a 623ZZ bearing, the generator cooling fan that's glued to the generator pulley, another 623ZZ bearing, and lock everything with an M3 lock nut. Spin it. It should rotate smoothly. Glue the bracket to the generator and insert a threaded insert into the bracket. This will allow the generator to mount to the front of the engine. Next, the fan assembly. Insert a M3x50mm screw through the fan bracket. Add 1 3mm washer, a 623ZZ bearing, the fan pulley which is glued to the cooling fan, then another 623ZZ bearing, lock it with a M3 lock nut. Finally, screw a M2x5mm screw into the cooling fan if your model calls for it. Again, check that it spins nicely. This will look great once the engine is running. Now let's close up the front with the timing cover and distributor. On the back of the timing cover, install magnets and make sure the polarity matches the magnets on the front of the engine block. Glue an M 3x4mm set screw and nut onto the timing cover where needed. For the distributor, attach it with an M 3x6mm hex head screw. Add magnets to the bottom and make sure they match the timing cover's polarity. Then screw the distributor to the timing cover using an M 3x8mm screw. Add magnets to the bottom of the distributor cap to match the distributor, and magnets to the rest of the terminals. Once everything lines up, install the timing cover and distributor onto the front of the engine block. Flip the engine over. It's time for the oil pan. Install magnets into the oil pan pockets, making sure the polarity matches the magnets at the bottom of the engine block. Then insert M 2x4mm set screws with nuts into the oil pan where required. Repeat the process for the front oil pan if your version has a separate front section. When you're done, the oil pan should snap into place under the block thanks to the magnet alignment. Now let's add the starter motor and electronics so this thing actually spins. Insert the geared motor into the oil pan starter flange. Lock it with an M 3x5mm screw. Insert the starter drive gear with an M3 nut inside. Lock it with an M 3x4mm set screw. Install a threaded heat insert at the top of the oil pan starter flange, then attach the whole starter assembly to the engine block. For the electronics, connect the DC female mount jack to the variable speed controller. Follow the markings on the board. Connect the geared motor wires to the variable speed controller outputs. Now your flathead can run off an external power supply with adjustable speed. Let's finish the top with spark plug wires, the last detail that makes the engine look real. First, cut the wire to the designated lengths. Place each piece into the forming jigs. Then use a heat gun at around 150 to 200 degrees Fahrenheit, 65 to 95 degrees Celsius, to gently warm the wire so it takes the shape of the jig. Let it cool to room temperature, then remove it. Repeat for all remaining wires. Next, install a magnet into each spark plug boot and match the polarity with the distributor cap terminals. Slide the wire holders onto each wire. Attach the spark plug boots to the wire ends, and connect the other ends to the spark plugs and distributor cap. Once everything is in place, install the completed spark plug wire assemblies onto the head assembly. Now it's time to put everything together. Snap on the heads using the magnets, mount the intake manifold, carburetor, and air filters. Attach the headers, generator, and fan assembly. Make sure all magnets and screws are tight. Finally, add the fan belt and the generator/water pump belt according to the PDF guide. You just built a 3D printed Ford Flathead V8. Let's fire it up. Plug your power supply into the DC jack. Turn on the variable speed controller. Slowly twist the knob to bring the RPM up. Watch as the crankshaft spins, the pistons pump, the valves dance, the fan, generator, and belts come to life. It's like a mini engine bay on your desk. If you enjoyed this build, hit like so YouTube knows more makers need to see this. Subscribe for more 3D printed engine kit assemblies. We're just getting started. And share this video with a friend who owns a 3D printer, loves cars, or just loves building awesome mechanical stuff. If you want to build this exact flathead, download the STL files from the link below and grab the MakerRx hardware kit so you can skip the parts hunt and go straight to the fun part, building. Drop a comment and tell me which engine should we print next? LS, rotary, something crazy? Thanks for watching, makers. Keep printing, keep building. See you for the next build.